All right. Okay. So till the previous classes, like we set up a Cloudera manager instance for us, which is this one. We named it as Cloudera manager as well. And similarly, after that, we on the same instance, if we check the host, we only have this instance itself, whose IP is this, which is hostname hyphen I will give IP of this address. So we only have this instance available in our cluster right now. But for any production cluster that you see in organizations, you have multiple instances there, and also what we are going to discuss today about the high availability scenario of HDFS service. Even in that case, we'll be needing more instances, more servers available for us. Now, one thing to be considered while adding instances in Cloudera Manager is that the configurations for all the new instances that you want to add should be similar to the one you already have. So I am looking to add instances with the same physical memory of around 16 GB, while it's appearing 15.5 because some of the memory is being utilized by the server processes itself. You can check what exactly the memory is from here as well with the command free hyphen h. So it's already showing like 15 GB available to us. 15 GB total, and out of that, 7 GB is currently available. So we will be having instances that have at least 16 GB of RAM available, so that it becomes compatible to the host that we already have. So let's just quickly uh, make those instances. One of the instances I've already configured over here. Let's just start this one, and also we'll make similar instance. So currently we'll be adding 3 instances. One we already have, 2 more instances. When I have hit this one, let me also create another instance. We'll be using the same version of CentOS that we have for other servers, which is this. So we need 4 GB and corresponding T, which is T 2.x large. So T 2.x large is you can get all these information from the lecture one as well. Okay, storage part. You can leave it as blank right now. Let's make it 30 GB. Tags SSH, and we can make it all traffic from my IP, as well as I'll also give. So this is basically the networking stuff, wherein we specify which server or system should be able to access this particular host that we are going to launch. So I have made it accessible to my IP, and I'm also making it accessible to this IP as well. Making it accessible to this IP over all traffic. So over networking, if we talk of, we have multiple ports and multiple kind of scenarios. One is where you only need to SSH, which is basically done on port 22. Similarly, if you want to do some other custom kind of thing like HTTP, which is quite similar to what we launched as a local repository in previous class. So that works on 80 port, but I'm going to open all traffic, which is actually of range from 0 to 65535 ports. So all these would be available to this particular IP, which is my other Cloudera manager server. Let's give it a name as well. verify all the things are available. We'll be using the same key pair we used earlier for our other instances. And we'll start. All right. Let's just quickly go to our dashboard. Name it. Let's name it. Although we'll have data nodes on other three instances as well. All right. So now we are going to add new hosts. So basically, if you want to add any new host, this is like the main page whenever you open Cloudera Manager, and then you have to go to the host section over here, and then you can add a new host to cluster from this. But before going to that, I want to discuss a few things about what HA is, what high availability in Hadoop is, what in HDFS is basically, and why do we need it and how do we do it. Okay. So if I talk of the instances that I currently have, you can see I have an active name node available over here. Okay. Now in a scenario when our active name node goes down, for that case, let me just stop my name node right now. So earlier I can do all the HDFS, like if I run HDFS DFS -ls to see what all files are available under slash, I can see a temp and user directory. Let's see what's there in temp. I can see there are certain files like test2, test1 available for us. Okay, so all this information is basically managed by the name node. Now, in a scenario when, for example, this particular host is undergoing maintenance, or this particular host needs some other patches to be done, or in scenarios wherein there is a natural disaster or something in that area where the server is kept, in that case the server doesn't works, then what would happen? So let me create such a scenario here, and I'm going to stop my name node right now. So this is a scenario where we don't have an HA high availability available. So our main point of failure, which was name node, is going to be down. All right. So our active name node is down. Let's see what happens if I now try to run this. So it gives me an exception, connection refused. Although we cannot, like, we don't want to move to this particular section. It's quite visible that our name node is not able to connect. It's giving us a connection refused. Now, in this scenario, a basic troubleshooting would also be to check whether you are able to telnet. So whenever you want to see if a particular port or a particular instance is running or not, you can use the telnet command. What telnet does is, telnet followed by the host name followed by the IP. So in our case, the name node IP was 8020 as we discussed in last class. If you do a telnet, it's showing telnet not come out. Let me just install telnet first. So to install anything, you should be root user, and you will be using yum install nettools, I guess is the package for telnet. You can obviously search for all this stuff if you're not sure. It's already installed. Let me see if telnet is available. Okay. So as a first step, what you can do is to whichever tool you want to install, just type that part in the after the install option. Yes, so it is able to find a telnet package for us. Let's install it. All right. Now again, let me go to the HDFS user. Any commands you want to run in HDFS, you have to be a HDFS user. Now let's do a telnet over that IP followed by 8020, which is the port for the name node. And you can see it's giving me a connection refused, which was similar to what I did when I was doing a HDFS DFS. So this basically tells me that my name node is down. Now, is to avoid such scenarios wherein you have only a single name node which is active, and whenever this particular name node goes down, actually all your cluster is down, and it's kind of a scenario where the whole cluster is not available and your clients cannot access their data, which definitely no organizations want. To counter this thing, we have something called as a high availability, which is like this. So the background of high availability, if we talk of, in a standard configuration, the name node is a single point of failure, as we like saw in this particular demo. We had a single point of failure. If this particular name node goes down, we are not able to do anything in an HDFS cluster. Each cluster has a single name node, and if that host or process becomes unavailable, the cluster is as whole is unavailable until the name node is either started or brought up on a new host. So we cannot like give services to our clients who are paying us huge amount of money, or if we are a kind of a banking organization, our customers who wants to access their banking data, they're not able to access that. So we don't want such a case right now. So uh, to in a scenario where only we have one name node, we have to actually keep a person who would be available 24/7 to keep a track if a name node is going down or not, and then if it goes down, he'll be going to restart it. Or if a scenario is like a for a data disaster kind of one, he'll actually have to set up a separate server and set up the whole name node on that server. So that's very time consuming kind of thing, and will incur a lot of cost for the time that you do all such activities, because your services are not available, right? So name node is either started or brought up on a new host. The secondary name node does not have provided the failover cap. So we see that already we also have a secondary name node kind of thing, but it is not able to service our clients because secondary name node is only keeping a track of the edits and the changes that are being done on the name node FS image, but it does not provide as services as similar to the name node, which is the active one. So this was for without an HA environment. The standard configuration reduces the total availability of HDFS cluster in two major ways. In the case of an unplanned event, such as a host crash, the cluster is unavailable until the operator restarts the name node. Second is planned maintenance. So we can have planned maintenance also on these hosts. In that case, we have to bring it down. You must have heard of scenarios wherein your bank messages you that we have a planned maintenance starting like 12 a.m. in the night till 4 a.m. and you won't be available. Services won't be available. So those are basically scenario wherein the particular organization doesn't have an high availability setup. So we can have like planned maintenance events such as software or hardware upgrades on the name node machine results in periods of cluster downtime. So cluster is actually down when this particular single node goes down. Similarly, now HDFS HA addresses HA is basically high availability. So high availability means like your cluster is 24/7 available even if a single node goes down. Now you can think of a scenario when both the nodes go down. So that in that scenario also the HA would fail, but it's a very not frequent that we see both the name nodes going down, and we definitely have a scenario wherein we keep these name nodes on a separate rack so that if a particular region is facing a kind of disaster kind of thing, at least the other region is available for this particular setup. If I talk of United States, I don't think Phoenix is a location or a region which faces many much disaster. I was when I was working for my previous organization, they had all their disaster recovery servers set up in the Phoenix region of US. So and the reason was it experienced very low disasters. So that's how you manage to plan and do things to keep at least one name nodes available for your cluster. So HDFS HA addresses the above problems by providing the option of running two name nodes in the same cluster in an active passive configuration. So the point is, if one name node is appearing active, which we saw right now over here, the other will be appearing in a standby or a passive mode. So although it would be functioning quite similar to an active, but it won't be writing the FS image edits, or it won't be writing, or it won't be surfacing all the clients that want to access data on your cluster. So that's what it means by the active passive configuration. These are referred to the active name node and the standby name node. Unlike the secondary name node which we have right now, the standby name node is hot standby, allowing a fast automatic failover to a new name node in the case the host crashes or a graceful administrator initiated failover for the purpose of planned maintenance. So what this means is it is a hot standby kind of server wherein if the active goes down, it will automatically fail over, or it will automatically make the standby which was earlier into an active this time. So if I would have an HA environment over here, I'll show you how it works. So if in that scenario, if I would have stopped this active name node, the other name node that I would be having would become a active, and in that scenario we won't be having a standby for the moment we again do not start it. So let's just see what all how do we manage such an environment to a new name node in this case that host crashes or a graceful administrator initiates failover for the purpose of planned maintenance. You cannot have more than two name nodes. Now you can think of having the scenario that we discussed. If both the name nodes go down, what will in that case happen? But you can think of having another name node, or like having 3 or 4 name nodes, but that is not currently suitable for Hadoop as far as concerned. We have something like federation where we have many name nodes all working in active, but it is something beyond the scope of this particular tutorial that we have. You can definitely read about federation, HDFS federation, wherein we have multiple name nodes and all are active. But for what general organizations use is an high availability only, wherein you can only have 2 name nodes available. All right. Now, let's discuss how actually the HA or high availability is configured. What is the implementation strategy? So there are basically 2 implementation strategies available as far as Apache Hadoop is concerned. One is QJM, which is actually quorum based quorum journal manager. So like whenever I discuss about any technical terms, you don't need to get too deep into what all it is about. You just need to understand that there is something rule kind of a thing which you need to follow. And in this case, like if I talk about quorum journal mail, you can think it of as a service of the name, only the name part of it, and there is no logical thing with it as far as how it actually works inside. Okay. So we have strategies of QJM, and then we have a strategy of NFS, which is network network storage kind of thing. Now, when we talk of Cloudera Manager, you can definitely read about what is NFS is, but we won't be discussing it more over here because it is not being used by Cloudera Manager. So Cloudera Manager 5, which we have right now, and CDH 5, which is basically the Cloudera, which is basically the Hadoop distribution of Cloudera, and we have CDH version 5.15 as discussed. It only supports the quorum based storage to implement HA. Now, what actually is quorum based storage? So, quorum based storage refers to the HA implementation that uses quorum journal managers. This is basically a service. It's kind of a service as you see over here as name node or the data node. It is just a service which is used to enable HA environment in a cluster. For the standby name node to keep its state synchronized with the active name node in this implementation, both nodes communicate with a group of separate daemons called journal nodes. Okay, let's first do one thing. Let's add the host and create a HA environment, and then I'll show you what all these actually services mean by. Okay, let's just add the host that we have. So you have to click the host section, then you have to go to the add new host to cluster. Tap to set up a Cloudera cluster. Oh, okay. So we have a service called Cloudera adapter, but we are not going to use it for now. We'll be manually adding the host. Okay. Okay. Over here we have to add the IP addresses. For example, if I need to add my name node 2, and in 2, let me give it the IP address, which is this. and also to add a node, data node, which is having the IP address of, yeah. So it will search. So it's able to detect both the hosts. Custom repository. So we'll be using the same repository that we used for our Cloudera manager host, which is basically the HTTPD service. Okay, start it. As we saw that this particular HTTP service was appearing down. Now, what you can do is, instead of manually restarting it every time, there is a command called system with system CTL, system control. Then you just have to enable this particular service, and what it will do is, whenever next time we'll be starting our server, we'll not have to manually restart all those services if we have it enabled. So next time I won't be requiring to restart my HTTPD service, uh, because we have already enabled it. All right. So what the reason that why I started my HTTPD service is to actually make my local repository, which is which is the one that we used the last time when we installed our Cloudera manager, which is this. So I'll be giving my repository, which is this over here, and the RPM JPG, which is what's actually this one. So let me copy the link. If you are like confused how this particular URL is available and how did I set it up, you can actually refer my previous lecture, wherein I discussed setting up local repository. Actually, my first lecture, wherein I have discussed setting up the local repositories. All right. Uh, so we have to give the JPG key over here. Continue. Continue. Okay. So we'll be using the same user we actually used to log to this particular host. So like when I was SSHing over, SSH is basically a service of to connect to that server from your local. So this was my local system, Windows environment, and I used SSH to connect to my server, which was this, using a key which was this. Okay, so the user that I use was actually CentOS. So the similar user I'll be providing over here, CentOS, and I'll be giving it a private key, which is this, which was actually what I used, the training key.pem. I will add it from here. Um, all other things you can leave, and I told you the SSH port is 22. It is already mentioned. Let's just continue. So you can see now it has started installing, and if any issues it would face, it would give us an error over here. So okay, like it has given me installation failed. issue. Could not contact SCM server 7182 SCM server. Okay, not found. I think it's something with. So if you face like any such issue, right, you have to just check for the details. And if even that those doesn't work, you have to go to the host and check whether there's some issue with the logs over there or not. Maybe try it. I think it's something with packages. Or probably okay. So the point is I didn't set up networking. So this particular host, which is my Cloudera manager, actually let me just show you how it is Cloudera manager. Okay. So the reason for this error is because it's quite clear from here. Could not contact SCM server at this particular IP at this particular port. So whenever you add a new host to a cluster, it actually tries to contact your SCM server, which is my Cloudera manager server, which is this. So the point is, I haven't set up an inbound traffic from this uh, to this host from the IP that I'm trying to add, which is these and this. So let me just check what all inbound traffic rules I have for my name node host. And how do you check it? You have to go to the security groups, and you have to check the inbound rules. Currently, it only like have inbounds from I guess. Although I've mentioned it, let me see why it is not working. I have to SSH over it first. Okay, I think I'll have to change it. Its inbound rule. Inbound edit add rule IP traffic. So my IP has right now changed because I'm connected to a different Wi-Fi router. That's why it's right today my IP is appearing different than the previous one. Now if I try to connect, it will connect. All right. So the reason that I connected to it was to actually check whether I can ping my other host or not, which is the Cloudera manager. So I'll be pinging this particular IP. And you can see the ping is not working. Again, let's go to the inbound rule. Inbound rules. And we have to mention the inbound rule over here as well. Edit it. And this time we'll be giving the inbound for this particular IP, which is my server IP. Host name -I. Let's give it also our traffic. is my NN2. Also, let me add it for the other IP, which is this, I guess. No, the second one. Ooh, traffic. This is my data node, I guess. Save it. Now let's see if I can ping it. Yes, now I can. So the point was, my host was actually not able to contact my Cloudera server, and now I have made that particular server available and pingable to both my Cloudera manager and the other two hosts. And now we have to retry it and see that if it works or not. Meanwhile, did you guys like go through and set up, like even try to set up your clusters till now? Evan?
Yes, boy, I tried.
So any difficulties or issues?
Actually, not yet. But the thing is that I tried that the previous one.
Mm-hmm.
I had some issue with the repo data. I don't know if it says some error or couldn't found. But
Mm-hmm.
I'll try to fix it out today.
Yeah, or if you like, if you really don't waste too much of time, you can directly contact Mohi, or you can just ping me also and give me an error over the chat, and we'll figure out what it's. So don't waste too much of
Okay,
time if you face issues, and you can, directly come
okay,
to me or Mohi. Okay.
okay, okay.
Okay. All right. Let's see uh, the details. What exactly it's trying to do, and if it's stuck at some place. Yes, it is stuck. It's giving me something like repo data, repo on XML not found, connection time. And the reason being, I have given the public IP over there. That's being the reason. So what I'll do is, I'll stop it for now. How do we stop it? Second. Somehow it is stuck. Let's see what we can do. Okay, so the reason was actually I gave the public IP, which I directly copied from here. Instead of that, I should be giving the private IPs, because when servers communicate with each other, it only communicates using the private IP, which is actually 1 second. So over here, I will replace it with the private IP of my Cloudera manager. This was a public IP which I gave. I have to give a private IP, which is this one over here. Similarly, followed by just before it is just after the CM we have it. Copy the link. Instead of public IP, I will be adding private IP. Okay. Let me also check for the installation, because I'm not going to do it manually. The same other steps would remain same. CentOS user, giving it a private key, which is this. Continue. And it will again start the process. And let's check what all step it's currently doing and if it's failing at some point or not. Okay, so one of the installations again failed. Let's see what is the reason. Okay, so it's actually couldn't install Java. What I'll do is, right, so you can see it was not able to fetch the Java packages. That's why it failed. What I'll do is I'll install Java myself on this host. So I'm already on this IP, I guess. Let me check if I have Java or not. I don't have Java. So yes, install Java. And I'll be doing it on the other host, which is this as well. Over here, give me option to install Java. And this is how you troubleshoot in production and in your organizations also. You'll have to figure out what would be the reason things are not working, and you'll definitely find something when you check the details or the log section of the server. So over here, giving me some error like another app is currently holding the yum block. What you can do is you can check which app is actually loading. So I'll do a ps-ef grep. So this is the particular application which is currently trying to, I think, trying to take a log. So what I'll do is I'll kill its process ID, which is this. So I have the command I like kill followed by L9 to kill it abruptly, and then the process ID, which is this, and also I'll kill the second process, which is 52. So 752. Now if I check PSF, it's not available. And let me just try to install Java again. Okay, it's again giving me. Okay, it's giving me the PID as well, I guess. Or basically, I think it's 448 448 PSF. Eight. Another app is currently holding the yum lock, waiting for it to exit. The application is Yan. Saturday, August 17, which is today. Running PID is this. Okay, now it has stopped, I guess. That's why we are able to install Java. So whenever you just have to read whatever information is appearing on your screen, and don't hesitate or don't worry about it. Like over here, our yum was not working because it's giving me that there is another application which is currently holding the yum lock, waiting for it to exit, and it was also giving me the PID for it. But after some time, it was actually the same one which we have like did right now while we were installing it. So that particularly was holding the lock of yum, and after it finished, it's trying to install it right now. Let's just wait for it to work. So adding host is a little tricky part because you'll have to make your host configurable and compatible to your cluster. So initially, once you add it, you can just play it around with the cluster after that. But you have to do all such basic stuff before adding nodes. I didn't do it because I just wanted to go as soon as whatever it demands me, whatever the cluster demands me, I can provide it right over there, and then I can move ahead. Okay. All right. So we have installed Java on both of our nodes. We have given the URLs. Let's go ahead. This time I'm not gonna click on this one because I've already installed Java myself. CentOS, choose file. Okay, this time it appears to be working fine. Installing certain packages. I think the Cloudera manager is installing. And, okay, let's see what's the second one. Requiring installation lock. Let's wait. First one seems to be working fine. Okay, meanwhile, all these things are appearing. Let's just see the theoretical part of what actually is involved in HA. So Cloudera Manager uses CDH like Quorum Journal Manager and quorum based storages, and for the standby name node to keep its state synchronized with the active name node. In the in this implementation, both name nodes communicate to the separate group of daemons called name journal nodes. So when we are done with adding our host, we'll go and make a cluster highly available. And once we do that, you'll see that there is another service called journal node available. So when any namespace modification is performed by the active name node, it durably logs a record of the modification to a majority of journal nodes. So when we have journal node services available on our clusters, basically in a multiple of in an odd scenario. So you'll have either 3 or 5 or 7 or 9 corresponding name nodes, corresponding journal nodes. So you can not have less than three, because I'll show you like what would be the scenario if we have less than three journal nodes. And so what now in this particular case, whenever any modification would be done on the FS image, or what we call like what we discussed in previous class, which is actually the namespace of your cluster. So all these modifications by the active name node would be logged in into the all these journal node services. And the reason being, these journal node services acts as a common place for all the two name nodes to reach and to see what all being done in the cluster. So earlier in without HA scenario, the name node was only managing writing as well as managing where these edits were being kept. But when we will configure an HA environment, all those changes or all those namespace writes would be done to the another daemon which is called journal nodes, which is this one. Now, the standby name node is capable of reading the edits from the journal node and is constantly watching them for changes to the edit log. So what will happen is the standby name node which we'll be having, right? It will constantly like keep on reading all these changes which is being written by the active name node on the journal nodes. And as the standby sees the edits, it applies them onto its own namespace. So this is a little bit it's theoretical stuff, and it can be asked in interviews. But you should know, like in an HA, whenever there is a journal node, the standby will keep on reading the edits that are being done by the active name node, and it will also keep on writing it in its FS image. So in this scenario, you have an active name node and a standby name node, which both are working quite similar to each other. But when clients tries to contact your cluster, it only goes to the active name node, and it doesn't go to the standby name node. But the standby is already doing all those stuff that active name node is also doing. So it is also reading. It is not able to write the edits, but it can read those edits, and it can apply those edits to its namespace to finally generate the FS image similar to what active name node is being doing. Okay. Now, this is was about the theoretical stuff. In the event of a failover, the standby ensures that it has read all the edits from the journal nodes before promoting itself to the active. So whenever the your active name node would go down, the uh, uh, standby will ensure that it has read all the edits from the journal node before promoting itself to the active. So before going to the active state, it will ensure that it has all the current cluster status which it has already read from the journal nodes. Okay, so one of our nodes is ready. We're facing some issue with this host, and the point is we are not able to see any details over here as well. So what we'll do is let's go to this host. I think we are already on it now. Let's go to this host and see what is an issue. I'm trying to see if I can figure out some process naming Cloudera, which I cannot right now. Let's check if I can figure out something with yum. So I can see it's still trying to info yum for the oracle. Let me just stop this process first. So kill -9. state as well, which is this. Okay, let's see we have Java in it or not. Java, Java hyphen version. If you want to check the version of Java, you can do it this way. Alright. Okay, so once we it was stuck on the info part, and once I just stopped it, it has moved further. So this way you'll get to know like what all is actually happening as soon as you have put your hands onto the server stuff, and you try, keep on trying. You'll face difficulties because you are quite new to all these things, but as soon as you go further, you'll be quite understandable with what actually was happening in the backend. But in this particular time, I would suggest you to not keep on trying. Whenever you fail, do not quit, just keep on trying. It might take you more than more the time what I am doing right now, but you'll have to keep on trying and have to figure out what actually is happening wrong with your server and why you're not able to figure out stuff. So my this course is, after I killed these two processes, which was stopping my host from moving further. It has actually moved further right now, and it's moving. It's now installing the Cloudera Manager daemons. So let's just wait for it to complete, and then only we can proceed with the other stuff. And I'll show you how you can enable HA and all, and we'll discuss the theoretical part also after that. Let's wait for it to complete. All right, it has completed. Now it will install parcels, which is the CDH parcel, which was actually it's trying to figure out from here the local repo CDH file. Yes, yes. So now it's trying to install these packages CDH 5.15 on the newly added hosts. And the progress you can see from here. First is trying to distribute, then it will activate and unpack and activate it. Try to read about Hawaii HA and what all these services. I will also be sharing this doc wherein I have already placed all the information, but you can also figure it out and you can also read about it from from the internet. What is a general node? What is an HA? And all. I will first try to implement HA, then I'll teach you a little basics about all these that I have right now. I think distributed part is quite complete. You can also track all the never rely when you are in a software organization. Never rely on the UI stuff, although it shows that something is. So one of the hosts has already completed, but you can definitely go and check the logs, which in this case would be the Cloudera SCM manager logs. I think it's completed. Okay, so since it's completed, we cannot. We just don't want to take our time into it, and let's just proceed further. Otherwise, what you would have done is you can definitely go to cd var log Cloudera SCM agent, and over here you could have tracked the progress from this log as well. To just print the last 10 lines, I'll do a tail -10 f over the log, which is this, and you can see that it was whatever it was appearing on the UI, it was trying to print in the log as well. Something like extracted one files from directory and all. So you could have tracked it from here. Now we have to perform the other basic things that we did in the initial classes as well. The swappiness, which we can do using something like this ctl vm dot swappiness equals to 1, and we have to do something like which is already printed on here, defrag and transparent hue pages enabled. All right. This was for this host. Similarly, we'll have to do the same stuff for the other host which we want to add to our cluster. Let's do root. So all these commands you can only run using the root user. Even if I try to run it, I think with the CentOS user, it will give me some error. Let's see if it does. Yes, so it gives me error for permission denied. Only root user has permissions to run all these commands. Yeah. All right. So once I have done it, I'll just run my inspector again, which will inspect my host for all those for changes. Okay, I think one host is still having issues. 206, 206. I want to. Okay, so I actually did it on the Cloudera Manager host itself. I missed it on 206, which I guess this. Let's see. No, it's 113. What is the IP for 206? 206. Okay, this is the IP for 206. Right. And the last part. Alright. Again run inspector. Something seems fishy. Let's go to the Cloudera manager. Let's go to the Cloudera manager and see what is wrong. Why it's not still processing. CD where log server this time and check logs. Yes. All right. So I think those warnings are now removed, and there's just a warning for Cloudera for the Java. We can ignore the Java part. Let's go further. Okay, you can ignore the created like template or stuff which is appearing, and let's continue. Okay, it is now deploying my yarn hyphen HDFS. So these are basic things that Cloudera defaultly does. You can like, what it's doing over here is basically it's deploying the configurations of yarn hyphen HDFS on the two new hosts that we added. And now after finishing it, you'll see the two host appears on your cluster. All right. So since now I have my host, but currently I don't have any role of HDFS or yarn available on these two hosts. Let's just quickly go to the HDFS and enable HA. Now, how actually you would enable HA is basically, let's go to this particular, I'll discuss all this theoretical part of what actually does in what actually appears in HA. And so you should be knowing the configuration of hardware, which I already mentioned. It should be similar to what you have in your Cloudera manager. Like to deploy an HA cluster using quorum-based storage, you should prepare the following: name node host. We already prepared our name node host, which was this one. This was quite similar of instance type and in memory and ranges to the what that I currently have on the name node on this particular host, Cloudera manager. And so they should have equivalent hardware to each other. I've already made it from the T2.x large on the AWS side, and equivalent hardware to what would be used on a non-HA cluster. All right. Now, if we talk about the general node host, which will be the service to install, these are hosts on which you run the general nodes. Cloudera recommends that you deploy the general node daemons on the master host or host, which is actually the name node or standby name node, which as well, so that general node's local directory can use the reliable local storage on these machines. So I'll be using the name node host only for the general node services as well. If core is located on the same host, each general node process and each name node process should have its own dedicated disk. You should not use SAN or NAS. So you can ignore these are basically shared kind of disk which are which can be shared by many other people and processes, SAN and NAS. So you should ensure that your journal node and the name node have their own dedicated disk available on the server. Also, the part that we were discussing earlier, there must be at least 3 journal node daemons available. Since edit log modification must be written to a majority of journal nodes. This will allow the system to tolerate the failure of a single host. So the point is why you cannot have less than 3 journal nodes, because if even if it is being internally known by all the name nodes that are a group of general nodes available. So if you have like two general nodes available, and if one goes down, the group will be splitted up, and name nodes would be in a kind of split brain scenario where they're not sure whether they can contact this one or not. So also there is a formula associated with the number of general nodes which your cluster can tolerate, which is n minus 1 by 2. And if I place 2 over here, 2 minus 1 by 2, it won't be like feasible for my cluster to manage. So at least a 3 general node scenario should be there, wherein you can at least tolerate 3 minus 1 by 2 failures, which is around 1 failure you can tolerate, and you can smoothly work with 2 general nodes in that case. But definitely you have to bring the third general node up. So this is what is being mentioned over here as well. This will allow the system to tolerate the failure of a single host. You can also run more than 3 general nodes, but to actually increase the number of failure the system can tolerate, we should run an odd number of general nodes. So 3, 5, 7, and so on. You can have in your cluster. Note that when running an n number of general nodes, the system can tolerate at most n minus 1 by 2 failures and continue to function normally. If the requisite quorum is not available, the name node will not format or start, and you will see an error similar to the error that is mentioned over here. Unable to determine input stream for KGM. So this is basically the IP which the author is actually trying to give an example for. All right. Okay. So let's just quickly go. This was actually the hardware part. Let's see the this one as well. In an HA cluster, the standby name node also performs checkpoints. We have already discussed it. It is not necessary to run a secondary name node. We will not be having a secondary name node or checkpoint name node or backup name node in our cluster right now. We'll be only having an HA environment. You can read about what is actually a secondary. So we have already discussed about a secondary name node when we already didn't have HA in our environment. There's something called as checkpoint name node, which only does the point of merging the FS image and the edits to create a checkpointing. And in case of your downtime, you can directly contact this one. Similarly, you have a backup name node as well, which is like keeping a backup of your edits and FS image. So we won't be needing, and most of the organizations don't have these three if they have an HA available. So we will be also be ignoring it. In fact, to do so, we've been error. Enabling HDFS HA. An HDFS availability cluster uses two name nodes and actually have a standby. One name node can be active. This is, and it depends on maintaining the log of the namespace. So we'll discuss about the theoretical stuff. Let's just quickly go on how we can enable our HDFS using the Cloudera manager. Okay. So you have to go to the HDFS part in the action section. There's an option for enable high availability. Click on this. Now, when I was, let me become HDFS user. When I was like trying to do something like HDFS, DFS, LS, I was actually just contacting my name node for it. So I was doing something like HDFS, DFS, HDFS colon double slash, then my name node IP, which was over here, it was 172.31.37.182, followed by the port 8020. And when I was doing this, currently I think the name node we have like intentionally brought down, so it will not be me. So a name service would actually uh, replace our dependence of the name node IP that we have to give every time we were trying to give the cluster path. So what in an HO environment you have an active and a standby at the backend. So whichever is active and whichever is standby is actually being managed by a cluster, and you just have to give your name service to make your cluster determine whether it's running with it. So let me just show you first by starting the name node again, which we deliberately brought down. It would be also be required in case of RHA. Let's start it first. All right. Try to do this again. Yes, so now we are able to see our repos, which is temp and user. You can see that we have to deliberately provide a name node and corresponding port. But in case of an HA, since you will be having two name nodes, and your cluster would manage which one is active and which one is standby. So every such thing will be replaced by a name service now. Let's give this name service like name of something like star name service. It all has to be small. Then you have to provide the other host. So we already had a name node service running on this particular port. Now the next host which I would give is that basically the name node 2, which is I think having IP of, so name node 2 has IP of 113, this IP, which is 113, which is this. Let's make it name node 2. Okay. And we have to give 3 general nodes as we discussed over here with the formula. You must at least have 3 general nodes. So we'll be giving general nodes on all the 3 hosts that we have right now. Okay. Now some basic configuration that the name node has already done. It's showing over here. Now, as we mentioned that we have to specify a separate directory for general node. Let's just give it in HDFS/jn. So in this particular directory, general node will be keeping all its edits and other things available. And as soon as we do it, now the cluster will automatically, start doing the stuff it needs to do as part of HA. So first, it has stopped the cluster. It has created certain roles. It has deleted the secondary name node role. Checkpoint directories of secondary name node will not be deleted, which will be used while doing an HA. It has made it available. It has installed a service called Zookeeper, and it's starting the general nodes over here. All right. In the meantime, all these steps are covering up. Let's just quickly go to the concept of what is actually being done. So we discussed about journal nodes and how journal nodes it acts as a common place to keep the edits. It should be in a group of 3 or more in the odd number form, and the standby name node which we'll be having right now will always keep a track of journal node for all those changes being done to the edits, and it will keep on merging it and keeping it fresh the corresponding FS image which was actually being generated on the active name node as well. And in case of a failure will occur, it will use that particular active FS image to turn into an active name node. Now, to provide a fast failover, it is also necessary that the standby name node has up-to-date information. To achieve this, the data nodes are configured with the location of both name nodes, and they send block location information and heartbeats to node. So, in case of a non-HA cluster, you must have seen that the name nodes were the active name node was only given information from data nodes, and the standby was only reading the active name node for whatever was being done. But in this case, the data node will treat both name nodes as the priority name nodes, and will give it information about the heartbeats, about its block location and everything, so that both the name nodes are in a coherent state of knowledge about the cluster and their services. It is vital for the correct operation of an HA cluster that only one of the name nodes be active at a time. So you cannot have a case wherein both the name nodes are in an active state. So at least only one name node should be active, while the other should be in standby. Otherwise, the namespace would quickly diverge between the two, risking data loss or other incorrect results. To ensure the property and prevent the so-called split brain scenario. So this is something which is most oftenly asked in interviews as well. What is a split brain scenario? So basically, a split brain scenario is a case wherein your cluster is not sure which is an active and which is a standby name node, and to prevent it, you should always be having two name nodes, and one should always be active while the other should be standby. Otherwise, uh, in a split brain scenario, what will happen is you cluster will try to consider other host, or both the host as active and or either standby, and will not because there's a possibility that it doesn't write the current changes to the edits, and if that doesn't happen, you might be a situation where your name node is not aware of any new data that is being written to the cluster, and there could be a data loss scenario available. Otherwise, the name state will be diverged between the two, risking data loss or other incorrect results. To ensure this property and prevent split bin scenario, general nodes only ever allow a single name node to be a writer at a time. So whenever when the name node is active, only that is allowed to write to the journal nodes directory, and which we configured to be -DFS -JN, and the other name node which will be the standby name node will only be reading that particular edit. It will not be allowed to write. But during a failover, the name node which has become active simply takes over the role of writing to the other nodes, which effectively prevents the name node from continuing in the active state, allowing the new active name node to safely proceed with failover. So you'll have to like give it some time, give it a read once or twice, try to understand what is actually happening. Because this is something which will be asked in interviews, like what is a split brain scenario? Why do you need journal nodes? Why do you need odd number of journal nodes? Okay, I can only discuss the basic stuff about it, but you should be going deep into it. Give it some time as well. Meanwhile, over here, HA is done. Successfully enabled high availability. The following manual steps would be performed. Configure the HDFS web interface view. So we'll do it as like as a troubleshooting thing when we work with Hue and Hive. We'll ignore it right now. All right. Once we finish it, let's check our instances and what all is appearing. So now you can see we have new services added. One which was our active name node, other one is our standby name node. We had 3 journal nodes added. Also, there is something called failover controller. Now, what this failover controller does is we'll actually discuss it right now. It does the automatic failover for us. Now, on both the name nodes that we have we have right now, we'll have on these name nodes a similar service available, which is failover controller. Let's go to the name node instance. Let's go to be on this one itself. Over here, if we have a service name node, we'll also have a sub-service name ZKFC controller kind of thing. Yeah, so DFS ZK failover controller. So every name node that we have that we install, there'll be another service ZK failover controller also available. What this will do is it will keep a track whether our name node is up and running or not, and it will ensure as soon as our name node service goes down, the ZKFC will report it to the other ZK to create a lock on the Zookeeper services and correspondingly make the other node active. A little bit theoretical stuff. I have tried to explain it over here, but you can also read it from yourself. So this is a concept of automatic failover wherein we don't have to keep a track of how a particular name node goes down and how the other becomes active. I'll show you like how the other will become active in a kind of time over here. But on a theoretical part, so automatic failover relies on 2 additional components in an HDFS, a Zookeeper quorum and the ZK failover controller, the same service that we talked of right now over here, which is this one. So process in Cloudera Manager, ZKFC process maps to the HDFS failover controller. So we can see that on the Cloudera Manager, it was appearing something like as failover controller service. Apache Zookeeper is a highly so. Apart from this ZKFC controller, we also the service that will also be involved in automatically failovering is this, which is Zookeeper. So Zookeeper will keep a track of the status from the ZKFC service, which I mentioned over here, this one. So it will keep on reporting to Zookeeper, and once a name node goes down, this service will report it to Zookeeper and say that this particular node has gone down and make the other node active. And what Zookeeper will do it will create a lock scenario to the other name node so that only that becomes active and is able to write to the journal nodes. So Zookeeper is a highly available service for maintaining small amount of coordination data, notifying clients of changes in data, and monitoring clients for failures. The implementation of HDFS automatic failover relies on Zookeeper for the following functions. So these are two functions which actually Zookeeper does. Failover detection. Each of the named node machine in the cluster maintains a persistent session in Zookeeper. If the machine crashes, the Zookeeper session will expire, notifying the other named node that the failover should be triggered. And how do you then active name node election does? So Zookeeper provides a simple mechanism to exclusively elect a node as active. If the current active name node crashes, another node take a special exclusive lock that I talked about already, indicating that it should become the next active name node. Now the service that was running on Zookeeper is a Zookeeper client actually, which is in direct contact with the Zookeeper service, and it monitors and manages the state of the name node. Each of the hosts that run a name node also run a ZKFC, which I have already showed you over here. So it was running a name node. Similarly, on the other name node also, you'll see a service like this. Okay. The ZKFC contacts its local name node on a periodic basis with a health check command, so long as the name node responds promptly with a healthy status and all. So it actually maintains a session kind of thing with the Zookeeper as well as with the name node service. And once it detects the name node goes down, it contacts the Zookeeper and says make the other node as an active. We have already discussed about the hardware, and we have done this particular thing from the Cloudera manager. All right. So there is also a concept of fencing method. First of all, let me show you how a failover take place. For example, let's go to the HDFS instances, and let's just start it. Probably we are running some issue with data node. Okay, we can ignore for it now. So let's see. This one is currently acting as active name node, right? And its IP is this. Let me just stop it, and we'll see that standby will now become an active one, and a cluster will still be available for us to read about it. So let me just stop this name node. And as soon as it stops, you'll see the standby role will become active now. Right, some issues with my cluster. It's still not appearing. Okay, so we will be replacing it with a name service now, which is star name service. Right. So you can see that even though I have stopped my cluster, the name nodes, although the other one is still appearing name like standby. I have to see what is the reason with it. If I open this one, this is actually stopped. Let's just go to the other one. Right, now you can see once it appears not running, the other has automatically become an active name node, which is over here. So the scenario that we were facing in a non-HA environment, wherein the name node went down, we were getting some error like this, which was over here. But in our case, once the other name node has gone down, but still we are able to contact our cluster with a name service, which is this. All right. Let me start it again, and now it will become a standby one. So this was the whole concept of what is actually HA done for, and why it is required, and how do you do it, and what are the services which are involved in an HA. Now there is something called fencing as well. Now we discussed about the scenario wherein only one active name node is allowed to write on the journal nodes. So this is actually being done by something called fencing. To ensure that only one name node is active at a time, a fencing method is required for the shared edit directory. So it's basically a fence around the shared edits directory, which we configured on the journal node service, something like DFSJN. So it's like a fence over it, and during a failover, the fencing method is responsible for ensuring that the previous active name node no longer has access to the share. So once we have stopped this name node, and it becomes an active, it becomes a standby one, which will eventually appear over here. So the fencing method actually ensured that this has revoked the privileges of writing over the journal nodes edits of a file. And by default, what Cloudera Manager, we have multiple fencing methods available as part as Apache Hadoop. You can search it over the internet, but what the Cloudera Manager uses is basically the shell fencing. You can check this particular thing from the UI as well with certain property. Let me check if I can check, if I can figure that out for you on the configuration. If I search for something like shell, figure out. Yeah, so you can see the HDFS high availability fencing method, which is actually being governed by the property. This is shell, which is a default one. All right. So this was about fencing. Now, what all are the basic properties which are involved as part as the HA is concerned? So one is FS default FS, which is actually the name service which we gave, right? So in our case, it would be something like this, star service name. So let me just replace it. And in over here, similarly, you can replace it all in other parts. And how do you figure out from the command line all these properties? Although it would be appearing on the UI as well. Like if I do it over here, it will give me what all properties are actually associated. So name node, name service, journal node, quorum journal node, journal services, and this property name. But on the command line, if I talk of, you can check all this stuff in directories known as run process, sorry, run Cloudera, agent, process. Over here, you have to see the name node process. Okay, so root doesn't have permission for it. Oh, sorry, HDFS doesn't have permissions for it. I have to go to the root user. Well, something like HDFS name node. Let's go on this. 91 is particularly let's do a tab over 91. So yeah, so in this file you can see there are two configuration files, HDFS site and one is core site. So you can check these properties from, like if I talk about FS default FS, you can definitely check it from this file as well. If I do a cat over core site, if I grep this particular property, you will see that we have this property and its corresponding value available over here as well. So A2 is basically giving me two more lines above the default FS, above the point that I want to grep, and B2 is giving me two more lines below it. So I'm able to find the complete property value from here. All right. Choose my terminal. So this was like basically what all HA is and how you can figure out the properties value. And I discuss about the properties because in the case where in an environment your Cloudera manager is down and you're not able to change anything from your. Although you should always prefer to bring the Cloudera manager up, but if you're still your cluster would still be running at the back end, and you can directly go to the shell and check for these properties. And if you want to reply it back to some of the your customer or for client, you can definitely check in this files, the Hadoop HDFS side XML as well as the core side XML as well. Okay. Okay. So till now we have discussed also similarly you can check out for all these properties like DFS name services, DFS corresponding the name node that you have mentioned. So all these things are actually being managed by Cloudera Manager as and when we did it from the UI. Otherwise, if you can do it from the without the UI also, you'll have to keep a track of all these properties as well. All right. Similarly, all these properties are mentioned. So you can just give it a read and probably. Although not being asked in interviews, but you should still be aware about it because these are being the main priority properties as far as HA is concerned. Okay. So similarly, you can fail over if you want to do a maintenance kind of a thing, and you don't want to stop your name node like I did to switch it to another state for the other name node to become active. You can also do it do a switching, but right now this is at standby and this is the active. You can also do a switch over from UI with certain steps like click the instances, click federation and high availability, which is this, and once you click on this, locate the row for the name service where you want to fail over the name node. So federation is something wherein you have multiple name nodes. I already discussed, but it's not basically used from like many of the organizations, but you can definitely read about it. So in this particular case, you can click on the action part and you can do a manual failover. So what this manual failover will do is basically it will make this one host as active and this one as this one as a standby and this one as active. So it will just flip the current state. Let's just try and do it on here. If you do it, it will definitely do. It will definitely switch. I'm not gonna do it for now. Similarly, from the command line, there is a command like HDFS HA admin hyphen failover, and if you run it from here, HDFS HA admin hyphen failover, what this will do, this will similarly do the effect of what this particular button will do from the UI. So you should always be aware of what you can do from the UI from the command line as well, because in a case wherein this UI is down, although your cluster will be up and running at the back end, but to do any stuff, any changes on that in that scenario, you can definitely use the command line and the corresponding steps like this. All right. So I've already discussed about the fencing methods. All right. Now let's quickly discuss some of the basic and important commands that we have. So we already discussed about HA admin failover. Similarly, we have other commands related with HA admin as well. If you just type HDFS HA admin, it will give you all those available commands that you have. I've also mentioned it on this page over here. So we have something like transition to active, which will make our standby become active. Similarly, we have transition to standby, which will we have to give command like HDFS HA admin followed by this particular like option, which is transition to standby. Then the service ID. Service ID is basically you can figure out from the UI of your name node, like from here, the active name node UI. Basically, service ID is basically your name service kind of thing, and you can give it, and you can make your node which is active and become it a standby one. Similarly, the failover part I already discussed. So failover is basically for failing over and making the static to the standby to active and the active to standby. And you can do something like get service state as well to check whether this particular name node is active or whether it is a standby. So all these steps you should give it a try on your cluster and check what all you can figure out from them. This was about HAdmin. Similarly, there is certain commands with HDFS name node. You can definitely check it from here as well. HDFS name node. Just do an enter and it will give you. So currently it's trying to start a new name node, but you can do something like help, and it will give you all those things available with the name node stuff. All right. So I've already mentioned it on this part, this document, and you can definitely check it out from the Apache UI as well, Apache UI, which is something like this. You have all those commands available over here as well. Okay. I have mentioned that particular URL in this part as well. Now, the most important stuff is basically the DFS admin, which most of the time is being used, and we have many options available. I'm not going to discuss all of them. You can definitely try it on your cluster, but we have already done something like report and safe mode check, how to enter a safe mode and safe namespace in our previous classes. And there's something called as quota, which being set. We'll discuss it in next in the upcoming classes. What actually quota is, what actually space quota and corresponding things is. So it's basically restricting a particular directory for the space requirements of it, and how to ensure that no more than that particular spacing will be used by that particular directory. It is something called as quotas. So I've added all these things in here. You can, if you are available, like if you have time, you can definitely try all these commands on your clusters. Yeah. All right. FSCK we have already discussed in I think the first class, how you create an FSCK file and how do you check. All other options are also available in this document, and we can go through it. All right. I think we can conclude with this stuff. We discussed about the HA and how HA works, what all services, how to fail over, how to manually fail over, what all commands are involved as part of HDFS HA admin and HDFS DFS admin is concerned. But you can only learn it when you do it on your own clusters. I always uh, push it for this part that go to your system, make a cluster, or do all this stuff on a cluster. Then only you will understand 100% of what we all have been discussing so far. But me doing it is something like because I have already known what all issues might have been and how do I solve it. I've tried to make all those issues available for you as well, but until unless you do it, you cannot understand what your understandability of an issue and how to resolve it. All right, I think we can stop this discussion for now. If you have any questions, you can just shoot me.
I have,
Yeah.
yeah.
Who's this?
Hello. Yeah, I have one question.
Yes. Yes.
You actually,
Mhm.
how many name nodes work under your journal manager? I mean, how many name nodes? I mean, let's say I have a uh, three node, right?
Mhm.
So three, or maybe five node.
Mhm.
So let's say five node. So how many? Like my name node, then secondary name node. It is like regular process.
Mhm.
Also other like a data node 1, data node 2, data node 3.
Okay.
My question is your journal,
Mhm.
how many name node can manage? All of five
No, no. So,
or I
Raj, you're a little confused. So the point is, you in an HA environment, you have two name nodes. You cannot have more or less than two name nodes. One point. Second point, as
Yes.
far as journal node is concerned, basically you should have at least three journal nodes, and if you want to have more journal nodes, they should be into an odd number. So you can have something like 3, 5, 7, and similarly going on in 9, and in the odd numbers. So
Or
the journal node and the name node are basically interrelated as far as the HA is concerned. And the number, if I talk of minimum three journal nodes and increasing in terms of odd, and two name nodes is always being like a requirement, wherein one is active and other is a standby.
so, I mean, if I mean, main primary name node went down,
Right,
then standby name node automatically take over.
right.
And
That's what I already showed you, right? If I go to
yeah,
the instance part,
yeah, very interesting. I mean, yeah,
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 it is.
I saw that. It's really very interesting. Automatically switch name node to standby, standby to
Yes,
name node.
yes,
So I'm talking about when if again my I mean, secondary name node now is a active non name node,
right.
and again my active name node is some reason down, then automatically previous one will be take over as
Yes,
active again.
yes. So if I right now would like switch it off, this currently
Yeah,
I made this active, right, in the previous step. If
yeah,
I now like stop
yes,
it, you'll see the other standby becoming active. Let me show you.
yes.
So it is always
So,
available. The cluster will always be available, and it will always ensure that if one of the name nodes active one goes down, the secondary one takes it's a part of converting into an active one. It might take some time in between because it is still appearing as active for the ZKFC. So that KFC service that I talked of, right, over here.
yeah.
This service actually maintains the state. So right now it's appearing active, but it's being like the communication is being taking place at the back end with the journal with the zookeeper, wherein the ZKFC service will tell him that my node has gone down and make the other node active. And as soon as it makes it available, it definitely turns the other one into an active one. Like,
Okay,
like
okay.
you can see right now, the first one becomes
My
active.
Yeah,
Second one
yeah.
is still
My
active.
question is, I mean, if two is down, then journal take over any uh, other source of node. Like I saw the journal node started journal node, three journal
Yes.
node over there.
Yes, right.
So if two is down, active and standby, then another name node take over of through
No,
journal.
no.
No, no.
So you have to, like you have already mentioned which two name nodes, which two host will be hosting the name node service, right? Apart from these two, no other host will be allowed to, make it in a name node. So you have to ensure at least one of them is available. That's why I talked of something like a disaster recovery scenario, and I talked of a place like Phoenix in the US, which is being already like regarded as a disaster-free kind of place. And most of the organizations, keep their one of their servers in that one of their like racks in that particular environment, so that they ensure at least one of their nodes is always available. Okay, as soon
So
as you fix the
this,
second one.
yeah. So this function goes through journal, right? I mean, take
Yes.
over standby to active, active
No,
to standby.
no. So journal node is only like storing the edits and the changes which are being written to the namespace by the name node. Okay. This
Write the
part of
name.
yes, this part of switching an active to standby or a standby to active is actually done by the failover controller. The failover controller
Uh,
is and with coordination with the zookeeper. So state,
oh, yeah,
yes.
yeah, yeah.
When we talk of
Thank
state, it is always the role of zookeeper along with the failover controller service to ensure which one becomes active and which one becomes standby. And when it is about the edits being written and edits being shared by the two name nodes, then the concept of journal nodes comes into it.
Uh, so
Okay.
only Juko only one function for failover.
So
I mean,
zookeeper.
how many jobs
Mhm. Yeah, so
by Juko?
Zookeeper actually it keeps tracks of not only HDFS service. We'll discuss it in the next classes as well. So edge-based service, if I talk of something like high metastore, not high metastore, but basically edge-based service as well, right? So Zookeeper keeps a track of the state of all these stuff. Also for the yarn, if you talk of HA part, it keeps a track of which becomes the active resource manager and which becomes the standby resource manager. So this basic stuff of keeping a track of state is being done by the Zookeeper.
But that is a very important job, like
Right,
failover control,
right,
zookeeper, right?
right.
Another
And,
one, another
yeah,
one,
go ahead.
another one quick question. Another. Actually, I'm always confused about that. How many actually how many properties for Hadoop system like HDFS system, like you mentioned, core XML and
Right.
HDFS side XML. Only two core file, or we have more than two core file?
When you
How
talk of
many core?
HDFS, you can check it from from the server as well. But as far as HDFS is concerned, the core side XML and the HDFS side XML is sorry, solely
Uh,
responsible for all the properties for the HDFS.
uh, so only two properties there need to be run Hadoop system, right?
Yes, these two are the basic one. We apart from that, we also have certain properties which are legal, which are not so important as far as now is concerned. But if you want to give something to your client about how they connect to your cluster, then you can definitely check all those stuff from your HDFS side and core side. Something like I
No.
talk of whenever you have a certain client. For example, a new client is added to your organization, right? And your manager says
Yeah.
that give your client the endpoints of your cluster. So what you're gonna do is you'll give this particular properties and its value. So you will be giving him something like default FS and its corresponding value and the name nodes, name and corresponding ports. So all this stuff you can always figure out from the HDFS side and the core side itself.
Oh, yes, yes.
Okay,
The only two properties, right?
right, only two files.
Okay, okay. Thank you, thank you, thank you.
Okay, so
That's all.
any other question? I see other people are also going. Guys, you have to do it on your clusters. Otherwise, then only you can come up with questions. I guess you guys are not following it or what. I don't know. But once could get your hands dirty, then only you will figure out what all difficulties would be. I think Daraj is the one who is doing it regularly. Others should also keep on doing it on themselves. Okay, if you don't have any other questions, let's just stop the session. Thank you all for joining.
Okay, thank you, thank you.
Okay, well, see.
Sorry, who's this?
Oh.